Hi everyone, this is Dr. Nak, and we're going to go over our practice exam number 2, part 2. And for this portion of the exam, yes, you can use your graphing calculator and also your scientific calculator, whichever that you're comfortable with, go with it. But anyways, let's just get started. So number 1, a right triangle has a hypotenuse of length 5 inches. If one angle is 39 degrees, find the length of each leg. Round your answer to 2 decimal places. So let me just first start out with drawing a picture. Pretend that's a triangle, please. Alright, so this portion is going to be 39 degrees. Okay, and hypotenuse is 5. So let's just call this side A and a B. Okay, so first, make sure that your calculator is in degree mode because you're given 39 degrees. So make sure to be in degree mode. Okay, so let's take a look. So what it looks like, we have cosine of 39 degrees. This is going to be A over 5. Okay, so that implies that A is going to be 5 times cosine of 39 degrees. Now, if you punch that in the calculator, you should get approximately equaling to 3.89 after rounding your answer to 2 decimal places. Okay, so I'm just going to write it as A equals 3.89. What was the unit here? Inches. Okay, now we're going to do the same thing for B. Okay, so B, it looks like what? Opposite side over the hypotenuse, so that will be a sine of 39 degrees. So this is going to be B over 5. So that implies that B is going to be 5 times sine of 39 degrees. Okay, so punch that in the calculator, round your answer to the 2 decimal places, and you should get 3.15. So I'm just going to write B, maybe approximately equaling to would be nice, huh? 3.15 inches. Okay, so that was number 1. Now, let's go with number 2. Transform the polar equation to an equation in rectangular coordinates. So again, you're going to have to memorize your rectangular coordinates. So let me just write it out in red. So remember, x equals r cosine of theta, and then y equals r sine of theta. And just for kicks, r squared equals x squared plus the y squared. All right. But anyways, let me just try to rewrite this. So let's take a look. Oh, look, we are given r sine of theta. But isn't r sine of theta just y? So I'm just going to write it as y equals to 4. Wow. That was pretty easy, huh? Okay, so I'm sorry it wasn't too exciting of a problem, but here's my equation. Y equals 4. Okay. So now let's go with number 3. Transform the rectangular equation to an equation in polar coordinates. So we're going to go from rectangular to polar. All right, so again, I'm going to rewrite the conversion. So we got x equals r cosine, y equals r sine. Okay, so let me see. So the y squared is going to be r sine of theta squared. So let me just write that out. Y squared is r sine of theta squared equals 4 times x. Well, x is r cosine of theta. Okay, so that implies that we have r squared sine square of theta equals 4r cosine of theta. Okay, so let's talk about this a little bit. I know it is so tempting to divide both sides by r to make our life a little bit simpler. However, you cannot divide both sides by r in case the radius is 0. You cannot divide it by a 0. So what are your only choices? What is your only choice to simplify this? Okay, why don't we just subtract 4r cosine of theta from both sides? So we're going to get r squared sine square of theta minus 4r cosine of theta equals to 0. I think that's good enough. As long as you did not divide it by r, I'm good. So r squared sine square of theta minus 4r cosine of theta equals to 0. Okay, number 4. What type of graph does the polar equation r equals 3.5 plus 5.4 cosine of theta represent? Okay, so I want you to sketch the graph. So what you need to do is, since the previous problem, you put your calculator in degree mode, so make sure to put your calculator back into radian mode for this. Okay, so if you graph this guy out, you should get a limacon with an inner loop. Excuse me, you probably are used to my horrible drawing by now, but let me see. Oh my gosh. That is such an ugly limacon. Let me just try to redo this. Alright, so let me see. That looks even worse, but anyways, do the best you can to graph this out. So identify the graph. So that was just nothing but a limacon with an inner loop. So I'm just gonna circle that one. Okay, so number 5, a laser beam is to be directed through a small hole in the center of a circle of radius 5 feet. The origin of the beam is 30 feet from the circle. At what angle of elevation should the beam be aimed to ensure that it goes through the hole? Round your answer to 2 decimal places. So first, I'm just going to draw the situation out. Okay, so here's the target of the beam, and here's the hole. And pretend that's a circle of radius of 5 feet. So this radius is 5 feet. So this is going to be also 5 feet as well. Okay, now the situation is that the laser is over here. That's the picture of my laser. And distance from here to here, that's given to be 30 feet. 30 feet from the circle. All right, now the angle of elevation would be over here where the laser beam, you want the laser beam to go through this hole. I'm just going to make the hole a little bigger there. Okay, so the question is this: what is this angle? Theta. That's what the question's asking. So okay, so let's just take a look at this. This problem is not as bad as you think. Okay, so right here is our 90-degree angle. So notice that what we're given is what? 5 feet and 30 feet, which would be the opposite side of theta and adjacent side of theta. So that will be what? Tangent. So tangent of theta is opposite over the adjacent, which is going to be 5 feet over 30 feet. Okay, so that implies that theta is equal to arctan or tangent inverse of 5 over 30. Okay, now if you want this expressed in a degree measure, that's totally fine, but make sure that your calculator is in degree mode if you want the degree measure. So if you want me to write it down, degree mode. Okay, so anyways, if you put your calculator in degree mode and punch this in, you should get, this is going to be approximately equaling to 9.46 degrees. All right, so the angle of elevation must be approximately 9.46 degrees. And here you have it.